Summing up. A. Towards the periodic system. Between 1869 and 1871, the Russian scientist Dmitry Mendeleev ordered 63 elements according to increasing atomic mass, thus making the first version of the periodic table of elements. Mendeleev was the first to observe some regularity regarding the chemical properties of elements. B. The modern periodic table. The periodic table sorts the elements according to increasing atomic number, each column representing a group, and each row a period. The outer energy level, or shell of an atom, is called the valence shell, and its electrons are called valence electrons. The number and arrangement of the valence electrons, which is similar for a particular group in the table, determines the similarity of the physical and chemical properties of the elements. C. Consequences of atomic energy levels. Elements belonging to the same group have the same number of electrons in the valence level. Note that the terms valence level and valence shell are equivalent. The elements of group 1 have 1 valence electron in the outer level, those of group 2 have 2, and so on. Group 8 contains the noble gases. These have 8 valence electrons and therefore a full outer level. Lewis structures, or electron dot structures, are simple diagrams that represent the electronic structure of the s and p orbitals in the valence level. D. Periodic properties. The properties of elements vary regularly through the table due to the periodic variation of the electron structure. These properties are atomic radius and volume, ionization energy, electron affinity, and electronegativity. Atomic radius and, consequently, atomic volume are periodic properties of elements, decreasing from left to right across the periods and increasing from top to bottom through the groups. Ionization energy is the energy required to remove an electron from an atom, measured in kilojoules over moles. It increases from left to right along the periods and decreases from top to bottom through the groups. Electron affinity is the energy released when an atom in the gaseous phase captures an electron. Electronegativity describes the tendency of an atom to attract electrons that are bound to other atoms in the same molecule, and thus the tendency to form negative ions. It increases from left to right across the periods and decreases from top to bottom through the groups. E. Metals, nonmetals, and metalloids. Metals are good conductors of heat and electricity, bright, ductile, and malleable. Transition metals and lanthanides have metallic properties. Actinides are artificial elements that are unstable and radioactive. Nonmetals occupy the right side of the periodic table. Their chemical properties depend on their tendency to accept electrons to become negative ions. The elements of group 7 are called halogens. Metalloids have intermediate or mixed properties of both metals and nonmetals. F. Elements of life. The essential elements are those that, albeit in small quantities, are essential for life. The most important essential elements in order of abundance are oxygen, carbon, hydrogen, nitrogen, and calcium.